Data compression using the LZ77 algorithm. File sizes can range from small to excessively large, and that can introduce a number of problems. For example, big file sizes can crowd your storage, which is a problem because you want to fit as many things on your device as possible. Another problem that will arise is that bigger file size means longer processing time, which then leads to a slower machine. The solution to these problems is, you guessed it, the LZ77 algorithm. The idea behind LZ77 is to take similar data types and group them together based on similarities. For example, we have the words algorithm over here. Instead of writing this, we can just write 6 algorithm to indicate that the word algorithm will be repeating 6 times. Now let's look at something else besides repeating words. We have the sentence to be or not to be over here. And as you can see, the phrase to be is repeated twice. Now what LZ77 does, it takes the second phrase to be and counts how many spaces it is ahead of the first phrase to be and takes the length of to be, which is 5. So instead of writing to be or not to be, we can just write to be or not 13,5. Now this extends to stuff beyond text. For example, pixels and zip files and JPEGs and even GIFs.
LZ77 algorithm, which are used in PNG, GIF, and GIF, can benefit students. For example, when a student in art major has some drawings which are really huge sizes and need to submit them through internet or send them to professor directly, he or she will format and save them as image files such as PNG or GIF and compress them to reduce file sizes with GIF. So compressed image files reduce transmission speed and does not exceed required limited size of file in that website. Also, our student can have more storage to save other images on personal computer or external storage by freeing up spaces with data compression. Moreover, the processor of student's computer will perform much better by reducing spaces on the storage.
The LZ77 data compression algorithm doesn't just benefit individuals directly, but these algorithm is first benefited by huge organizations such as Google, YouTube, and Apple. For example, Google has cloud service called Google Drive that offers individual or smaller companies ability to share files and broadcast them very smoothly. Google uses data compression, LZ77 in fact, to store enormous amounts of data in the drive. This increases efficiency while reducing the cost for the service. Thus, this doesn't just benefit Google, but smaller organizations like UB take advantage of the Google Drive, and individual users like us use it in our everyday lives. Over 800 million active users have stored about 2 trillion files on Drive since 2016, which financially benefits Google.
One of the biggest cultures in the world is arguably the internet. In just 1 minute, over 640 terabytes of IP data is transferred throughout the globe. This is where data compression LZ77 comes to play. By compressing file sizes, 640 terabytes is much smaller than what it would have been uncompressed. LZ77 also impacts the speed at which data is transferred since it's much smaller. Also, over 240 emails have been sent in those 60 seconds, and although not all of them use LZ77, if it has a zip file or image file, which most emails do nowadays, it will be using LZ77, leading to the conclusion that the world runs more smoothly and efficient with data compression.